move from hardware centric into virtualized kind of environment. They need to move away from being a very static, network kind of stuff into an agile network. Data centers need to be more agile. So business requirements and infrastructure requirements. If you see, business requires a lot of agility and automation so that you can deliver new services, new applications very fast. And for that, you need to have a right set of infrastructure which helps you do automation, orchestration. That's where technologies like SDN will come and help you, build an agile and automated data center. You should be able to reduce your time to market for any service. Because the moment you think and you want to come up with new services, there are chances that your competitor may probably roll out those kind of services much faster than you and may leverage and gain on it. So the time to market for any new thought process, any new service needs to be rolled out pretty fast. Mobility is another thing which is driving the market, we all know. So the applications need to be designed in such a fashion that they're mobility centric, and they could be hosted within the data center or across multiple data centers. So what's happening to compute? Since we're talking about data centers, let's also try to see what's happening in the compute world. Let's also try to figure out what's happening in the storage world. And we'll also look into it as to why should we networking guys understand what's happening in compute. So if you look at 4 years back, there was 54% of physical compute, and there was virtualization on compute which had started and was growing rapidly, and we were seeing around 46% of compute being virtualized. However, if you look at by 2016, we will see the physical compute be 29% and virtualization would be almost up to 71%. So this shows that there is a clear-cut, growth in virtualization and storage, which is rapidly happening. But if you look at the networks, still you go and talk to any customer, or whenever we're talking to any customer or, getting their requirements, they're still looking at building a very static kind of network. You should look at, and understand that today the compute and storage has been virtualized, applications have changed. So your data center networks also need to be geared up or built in such a fashion that they need to be agile. You should be able to virtualize and roll out these new services pretty fast. So why do we say that, with all these compute and storage being virtualized, why is network a challenge out there, and why should we move from the physical, centric data centers into a more agile and more virtualized or more flexible data center? So today, if I need to launch a new application, I have 3-4 things which I typically do. I go to my app guy and I tell him that, okay, can you help me build my apps in place? And he says, okay, we'll have the app ready in next few days. And once my app comes in, that's where, I start getting the remaining resources in place to roll this app out. So I call my server guys, I call my storage guys, and I call my networking guys who also take care of security. So when I tell the network storage guys or the compute guys, this is the app, get it up and running, or, typically within few seconds they say that it will be up and running, because they just need to port it onto a virtualized server. Okay, virtualization of spawning a VM hardly takes roughly around 15 seconds to a 30 seconds time frame. And, you don't need any kind of outage, resources are available, unlike previously where they had to order a server, that those days are gone. And same thing happens on storage. But now I need to get this application rolled out onto the WAN, and that's where the challenges start coming in, or to my internal network. So you need to plug into the network, you need to get security in place. That's why my networking guys come up and say, okay, look, I would probably need some kind of outage, or I would need this time to this time, outage or some change management because I want to roll these services out. So network also needs to go in hand with the compute and storage, so that if these guys are able to roll out services in few seconds, at least on the compute and storage, we should be able to support them on the network so that they're able to roll these services out, fully within few seconds. That's where the network needs to be more agile, more flexible, more virtualized. So two problems with the data center networks, as we have been talking. One, impedes time to value. What do I mean by that? So as I said, when I think about, rolling out a new service or a new application or an idea, does my network or is my network geared up today to, roll out this service to the market or to my users at a fast pace, right? In that, all the various things which we discussed come in. The other thing is low value over time. The traditional networks which are actually built, they start losing value over time. What do I mean by that? What really happens is, if you see, the moment I start scaling my traditional network, it starts to break down. There's a lot of complexity which starts coming in and it starts to break down, or it is not able to, help me roll out these services at the pace what I'm looking at and deliver those services. Some of the other issues which the current approach to a data center has is scalability, as I was talking about. So there are multiple big organizations which want to have one common data center for their subsidiary businesses, and that's where they require multi-tenancy. So the physical or a static kind of network doesn't really help you there. So how do we go about addressing this? Second is programmability, is another very important thing which is needed today so that you can address the way applications are changing. So you need a lot of orchestration tools, a lot of programmability into your network. It's not only on the higher level, but also on the lower level or onto the switching level. Service insertion, you may one fine day decide that you want to drop in some security or some load balancing services for certain set of applications. Now, if you have a very static network, you probably need an outage and a reconfiguration of certain set of equipments to do a service insertion. However, if you have an agile and a very flexible network, well orchestrated, you can actually do a service insertion pretty easily out here. And the final thing is intercloud orchestration, or ability to orchestrate or integrate with multiple different data centers, which could be, in your own premises, could be hosted onto a cloud, or hosted, at a service provider side. So the MetaFabric architecture, as we know, helps address all these problems which we talked about in the data center area. So let's look at what are the different types of data centers which are being seen. So one is a certain set of customers build data centers on their own premises. Could be one, could be two, or could be multiple of them. Certain set of customers decide that, okay, I'm going to have one or two data centers into my premises. However, I'm going to probably have a certain set of data center which is going to be a certain set of applications which are going to be rolled out from a cloud service provider like Amazon or maybe NetMagic. Other guys may decide that I'm going to probably just go and host it at a service provider. In that case, he could go with a managed service provider option, or he could look at as a pure hosted service provider option. So when you do that, you also need to figure out how your application is going to work, right? In this kind of scenario. So in this kind of scenario, you also need to decide how is your VM migration going to happen. Are you going to serve your application from all the data centers, or it's going to be DCDR? If it's going to be DCDR, how is it going to work? What kind of time frames or failovers we are looking at, and so forth. That's where MetaFabric architecture actually comes and play a very important role. So the architecture actually is built on three basic pillars, which basically simple, open, and smart. And we're going to do a drill down into, what do we mean by simple, what do we mean by open and smart. So let's look at, what are the different components MetaFabric is going to address within a data center. So one, obviously, as we said, data center network. Second, it's going to address your connectivity between data centers. We call this interconnectivity of data centers, right? Because you will need to have the right set of edge in order to have multiple data centers which are going to be interconnecting. Now, apart from that, as we saw, right, we need to have this data center which needs to be agile, smart. How are we able to do that? So you need to have the right set of orchestration tool, which also helps you, do a network automation so that you can roll out your services at a faster pace. Okay, so that's another thing which MetaFabric architecture or guidelines help you to address. Apart from that, as we saw, services, network services is another thing which needs to be addressed, because you may want to decide that I want to roll out security services, I want to roll out load balancing services, caching or CDN services, right? So the architecture helps you provision or build a solution where you can actually go about rolling out these services. And then finally, help you also virtualize the network so that you can have multi-tenancy into the network without making any changes. So as I said, there are three key pillars for building a MetaFabric architecture: simple, open, and smart. So when we talk about simple, we are saying that it should be very, very easy for you to acquire and deploy these architectures, right? It shouldn't be that, it's a rocket science and I need to, spend so much of money because I want to acquire this kind of architecture. It's a reference thing, right? You can build and deploy this architecture based on these guidelines, not only with Juniper equipment, but you can have a mix and match of different vendors. Okay, that's where the openness of the architecture or the ecosystem of different vendors comes in. It should be easy to integrate. That will happen only when you have an open architecture and openness into your network. That's where it will be able to integrate. And it's not going to only integrate with your networking equipment, but it also needs to integrate with your storage, with also your servers, right? Because that's where your virtualization is going to be playing an important role. And to top it up, how do you go about making sure that you can automate and virtualize the network and orchestrate the network? That's where the SDN will come and play a very important role. And finally, the network needs to be intelligent enough, because if there is a slowness into an application detected, how do you figure out whether it is a networking issue, or is it a compute issue, or is it an application issue? You should be able to tap and pick up analytics from the network at multiple points so that you can figure it out where the problem is and go and fix it as early as possible. So a MetaFabric architecture obviously needs certain set of equipments to build this architecture. And what are the different components which actually help you, build this thing? One is switching. Second is routing. You need this for your edges to help you, interconnect data centers. Management platforms, which help you, build a smart and orchestrated data center. SDN capabilities, or a controller, which will actually help you give you SDN functionality. Security, and finally, some kind of services or solutions, because every customer may have a different set of needs. And for that, you need to use these guidelines of the MetaFabric architecture to rework the complete solution for you, and then finally go about rolling out these services. You will need some kind of professional help, which will help you, roll things out. So our data center journey, when I talk about our, that means Juniper, we started somewhere in 2008, and it's almost been 6 years. Thanks, guys, for giving so many yeses. So we started with, our switches somewhere in 2008, and then quickly we had our management platform, Space. Then we rolled out our tier, two-tier and flat or single-tier architectures, and collaborated with a lot of our partners to roll out a lot of automation and orchestration tools, because you need to have a lot of integration if you want to build very agile and flexible data centers. And last year we launched our commercial and open SDN platform, which is basically CONTRAIL. So CONTRAIL is available on opencontrol.org, and it's something which you can just go and pull it down and start using and building your networks which are SDN ready. I'm not going much into details of this. Anyway, we will be sharing our slide deck, but some of the figures, what we've been doing in the switching area and the routing area. One of the platforms which actually helps you, in MetaFabric architecture is recently launched a QFX 5100 family, because it has a lot of integration capabilities with different set of partners or vendors, I would say. So few key things what it does, apart from a lot of integration, and some of the slides further down will give you more details, is it gives you a hitless operation. When I talk about hitless operation, it's a single 1U or 2U systems available, and they can be upgraded without any reboot. It's the only TOR in its class across almost all the switching vendors where you can upgrade a system without doing a reboot, and this is happening on a top of the rack or a 1U or a 2U. It's not a chassis, right? So typically having an ISSU functionality on a chassis is something which is heard of, but having a TOR switch, having upgraded without a reboot is something which 5100 offers. Great capabilities on the feature set, and a lot of smart analytics which actually helps you build the third tier of the architecture. As you can see, it can participate into multiple different architectures. We've been doing virtual JC for almost now 6 years from the time we launched the switching. It also will participate in the fabric-based architecture. It will also be participating in virtual JC fabric architecture. It can work in a spine and leaf architecture, and it can also work in a layer 3 cloth or a fabric architecture, depending upon requirement. So there's a lot of flexibility this system actually gets across, where you can start with one architecture, and over a period of time, when you have a different set of requirements coming up, you can actually move into a different architecture. And that's where agility of the network comes in, and 5100 helps you address that. Because as I said, right, one of the things which we have been hearing is the network loses its value over a period of time, which is something which needs to be addressed. And that's where 5100 plays a very important role, that it has multiple different architectural solutions available, or it can participate into. And over a period of time, if you feel that you want to change few things, you can go about changing it. Okay, the other thing which 5100 offers is NSX integration, VMware NSX integration readiness onto the system. So what do I mean by that? One of the things is integration with VMware NSX, and we all know VM has launched their own SDN controller. However, there is a point where you need the virtual network to integrate or merge or have a marriage with the physical network, and that's where the QFX 5100 plays an important role, because you can have a termination point or VXLAN onto it. It can actually behave like a VTEP point out there. So the same system gives you flexibility, because when you want to do virtualization and you want to run multiple tenants, multi-tenancy onto the network, this is where overlay technologies like VXLAN, STT, NVGRE, MPLS over GRE, and so forth are going to be playing a very important role. The other thing, which again, other set of portfolios actually help you is EX9200s and MX series, which can again behave as an, point or gateway point for terminations between your virtual data center and your physical data center. Again, they support VXLAN. In fact, I will do a small deep dive onto MX series where we're supporting multiple different overlay technologies onto MX series, and it could also help you. It could also help you on infrastructure as a service kind of requirement where either QFX 5100 or MX series, can be used where VXLAN terminations can happen, or any other tunneling platform or tunneling technology can be used. So MX series is something which again we have been shipping for a long time, and the beauty is if customers have been using this, most of the systems would be able to support some of the key points which will help you, roll out new services into your network, which will give again complete flexibility and help you, deliver a lot of value over the network. So MX is something which behaves as a universal SDN gateway. So it could be your core router cum switch. You don't need to build multiple tiers into the network. It could actually do your dual job, and it could support VXLAN termination at one point. It could do L2 VPNs. It could do MPLS over GRE. It could do STT and so forth. It also helps you, as I said, you could use it as a router cum switch. It's something which can be used to build EVPN. It's a new technology which overcomes a lot of drawbacks which VPLS was having. However, it's an open protocol, right? So you can go about using EVPN between Juniper and Cisco as far as the drafts are matching. The other thing what we have seen is when you're doing VM migration from data center 1 to maybe data center 2, the gateway changes, and that's actually called that's a major problem which most of the people are seeing when you're moving the VMs across data centers. So the VMTO helps you, address those issues. So even when you move a VM from one DC to another DC, the VM gateway, the VM will use the same local gateway to move out and get the data back in, rather than going into the primary data center again. And it's got fantastic multicast and broadcast handling capabilities. And we know that, a lot of customers have a lot of multicast into their network. It has a replication engine, which is basically, which basically helps you replicate the streams on the card itself, rather than, having multiple streams being transmitted to the destination card or the receiver card. So as I was talking about, MX also helps you, behaving as a universal SDN gateway. And as you can see, we've got NSX, we've got CONTRAIL. So you could have two different controllers, different encapsulation protocols. So NSX will use maybe VXLAN, CONTRAIL, MPLS over GRE. You could have bare metals. You could have systems with multiple VMs running in different encapsulations out there. And MX is the single platform which can actually help you integrate between all these different tunneling platforms. So it could be one single point of contact where you can go and terminate different set of tunneling technology and take it forward. It also behaves as your data center interconnect. So you want to extend your VLANs, you can do that using EVPN, L2 VPNs, or VPLS. Choice is yours. So let's look at some of the SDN principles. Some of the SDN or general SDN principles say that let's separate whatever is required. Let's centralize whatever is required. Let's go about using the cloud wherever it is possible to the maximum. Let's go about using common platforms. use standard technology and standard protocols so that we have complete integration available and apply it broadly. Juniper's approach towards these have been narrowed down into 4. So we will centralize management. We will extract the services wherever, whatever is required. We will centralize the control. So the control plane and the management plane has been centralized. However, the services, I will extract it and use it wherever it is required. And I will go about optimizing the hardware. I do not want to, use or tell you that, go about buying everything new, but we will go about using whatever is available. And we'll go into more details on that. So how does CONTRAIL actually do that? So the CONTRAIL controller basically is a central, you can say, where we run the configuration control and analytics or the management stuff. We drop down a virtual router on every VM, on every hypervisor, I should say. Currently, what we are supporting is KVM and VM, and there will be multiple more hypervisors which will be supported over a period of time. That is, we're talking about Zen, we're talking about Hyper-V, and so forth. And we use the overlay technology like MPLS over GRE as of today. EVPN is also supported, and we will be going about getting VXLAN, NVGRE, GRE over UDP, and so forth. So this helps me now build an overlay network on the existing underlay network. And the beauty is I do not need to go about ripping and replacing all your switches. I don't need to touch anything on the underlay. I will build an overlay network on your maybe existing underlay network, or a rebuild or redesign underlay network based on the MetaFabric guidelines. And gateway is the point where I need few functionalities like support for MPLS over GRE tunneling, capable of running BGP, and so forth. So apart from that, security, as we talked about, is going to play another important role out here, because you may want to launch some services which could be security or load balancing services. So as we saw previously, there are different types of data centers, and these data centers will have different set of needs. So it could be a managed data center, okay? It could be on-premises data center, it could be a hosted data center, it could be a cloud data center. So data center security is now moving away from traditional box approach where you're talking about, okay, let me go and buy a firewall which should have IPS, which should have probably application-based policy capabilities, and so forth. It is actually started moving away from that, and we're talking about how you can go about defending, detecting, and responding to these attacks in a different way. And this is what we will see in the subsequent slide. So one is the firewall. Okay, that's the first or the basic line of defense, I would probably put it. And then you have certain more things which typically a firewall does. Okay, so a lot of firewalls, and same is the case with Juniper, that we go about supporting IPS, we support application or app security onto it, and you can run multiple other feature sets like you want to do URL filtering, you want to run some kind of AVs, and so forth. However, some of these are not typically recommended in a data center scenario. You need to start looking at some other points in the data center where you're talking about proactive identification of your hackers, right? How can you go about figuring out whether someone is trying to attack your network or trying to figure out what's happening into your network? Okay, that is something which we call it as a deception-based technology. We call it JWAS. So in that, basically what we do is we start sending tar traps or something like what we talk about, a honeypot kind of stuff. So we start putting tar traps on the data which is going out, or someone who's requesting for data. And the moment this goes out, if there is a hacker sitting there, he always tries to see, who's got the least security available. And that's where he sees, okay, here I've got a lot of loopholes available and I need to attack here. And once he starts, attacking, we know he's the guy and we can actually go about informing him that, look, you're being monitored and we know you're trying to attack, or we can start sending a response to him at a very slow pace, and a lot of other things can be done. DDoS, right? Application-based DDoS, where we have gone ahead, where we don't only look at the normal traffic anomaly kind of stuff in the regular DDoS stuff. We go to different levels of putting charm values to different set of traffic and figuring out, whether are we seeing some kind of deviations from that, and take corrective action onto it. A lot of times people talk about plugging in firewalls at the perimeters or across VLANs. What about if your VM got compromised, right? You have different tiers for your applications. You have a web tier, you have an app tier, and you have a database and so forth. What if your VM got compromised who was actually going and talking to different VMs? So if your VM got compromised, he's going to sit there and he's going to start jumping into the different VMs. How do you come to know? Because the security what you have built with respect to firewall is outside the VM. That's where host-based or the VM level firewalling comes into picture, and we basically call it a VGW, or a host-based firewall, or a Firefly, where it's actually sitting on the VM level, and it's seeing and protecting based on the configurations and policies which have been set in place for communication between VMs or outside the VM. So at different levels, different set of security need to be pulled in based on different data centers you are trying to build or you're trying to use for your environment. Finally, coming into the orchestration layer, as I spoke about, where you need to have complete visualization into your network. You should be able to analyze and control. That's where the Juno Space Network Director comes into picture. And the beauty about this is there are different third-party applications which can be loaded onto it. So one of the application is Firemon, right? It's a third-party firewall monitoring software, which is available to be loaded onto Juno Space, and it can manage multiple different vendor firewalls. You can have Juniper, you can have Checkpoint, you can have Cisco, and so forth. And the other beauty about Juno Space is it's got not-bound APIs which are available, which can be used to integrate with different orchestration tools like OpenStack, CloudStack, your VMware vSphere. In fact, we have another application called Virtual Control, which can be put across on Network Director, and it can help you, orchestrate or control your network the moment you are doing a VM motion from one server to another server. This actually helps you, give you a single pane from where you can sit and manage your entire network out there. So this is the reference architecture which I've just put across out here, and as you can see, there are multiple different data centers which are shown here, and on the lower side you will see that is a secondary data center. On the left hand of the screen you will see that is a private data center. On the right hand you have a public data center. So we basically build this data center using MX as a routing platform. It could also be your core switch for your network itself, because we want to simplify the network. And this is also, creating the connectivity between all your data centers, the data center interconnect, which we talked about in one of the reference points. Security, that is your SRX, which is being plugged in. And the beauty is security, again, SRX can be available on a single box, or you could, spawn a VM and get SRX functionality on a VM, and depending upon the performance, you can keep rolling out different set of VMs for more security requirements. SDN, the CONTRAIL controller or the Open CONTRAIL can be used for the SDN stuff. And on top, you can use OpenStack, CloudStack, or Smart Cloud from IBM, which could give you a single pane. And you can build a virtual network over this physical network. And on the switching side, you can either have Juniper switches, which have their own set of benefits, or you could go for any other switching vendor. There is no hard and fast rule out there. However, we would love to have a complete Juniper solution out there. So this is how the MetaFabric architecture, reference architecture is looking like. And when you're building a architecture which you want it to be very flexible and agile, you should look at the 3 pillars and what are the different guidelines for these set of pillars. Different technology alliances which we are carrying today, and this is something which is ongoing, which is in a process which keeps on growing. So you have VMware, you have IBM, VMC Software, Mirantis, OpenStack Cloud Scaling, and so forth. Right, almost all of the key players which actually are residing in and playing in data center space are partners out here. So MetaFabric architecture, as I said, it will help you build a simple, open, and a smart network, and help you accelerate the time it takes for you to launch new services or applications for your customers. So some of the key takeaways before I open up for questions. One is, one of the guidelines: keep your network simple, open, and smart. Okay. You should be able to integrate with different set of vendors. It shouldn't be locked down to one particular vendor when you're building this kind of networks. QFX 5100 is one of the leading industry store with a lot of functionalities like TISSU and good insight into analytics. You can use the same to build multiple different architectures. QFabric still remains our premium 10 gig offering for data centers. MX, Universal SDN Gateway, because when you're building a MetaFabric based architecture and you want to run a virtualized network on your physical network, this is the way to look at it. MX is really pioneer into it. Different set of partnerships which we are having with different vendors. VMWARE is one of the partners out here. And Juniper can help you validate the architecture, design the MetaFabric architecture, and also implement it using our professional services out here. Let us know if you want to have more information on a MetaFabric, or if you want some of our representatives to come and visit your office, do a face-to-face session or a deep dive in any of the topics or onto MetaFabric again. Do feel free to come back to us, and we will make sure that someone comes and catches up with you.